The basic problem on Quideo number 5, part A. First asks you to state the hypothesis. And first to do this, you have to define your variables. So p hat of 1 is the true proportion of HIV patients who develop AIDS with the drug AZT. And p hat 2 is the true proportion of HIV patients who develop AIDS with the placebo drug. And from here we can state our hypothesis, which is p hat will be equal to p hat number 2, so the AZT drug will equal the placebo. But for the alternative hypothesis, p hat 2 would be greater than p hat of 1. And this means that more people will develop AIDS with the placebo than the AZT drug. So the AZT drug will lower the amount of people who develop AIDS. And after that, you have to use your assumptions to see if we can actually do the test. And in the problem, it states that isn't an SRS, and we assume they're independent. So like each patient doesn't have an effect on the other patients. And then we have to see if 10% or 435 is less than 10% of the HIV taken AZT drug, which it is. And then here, you like pull the data, so it would be, or the data is pulled, so it would be the two proportions, or the two like total developed age, which is 38 plus 17 over the number of both, which is each are 435, so you add them. And then from here you get your proportion of 0.0632. And then so NP hat is equal to, well, you just multiply them together, and 27.5 is greater than 10, so that checks out good. And then NQ, which is 1 minus the p-value, and that also checks out to be a lot greater than 10. And these are the same for both NP of 2 and NQ of 2, also because it would just be flipped. It would be the same proportions. Part B wants to know how significant is the evidence that the AZT drug is effective. So to do that, you want to find the p-value to start. So to do that, you use this formula, which compares the proportions. And then when you plug in the numbers, so this is the proportion, and then p and q. Q is just p minus 1, which is given in the problem. You solve for this, and it gives you a value of negative 2.93, which, if you look in the z table, you get p equals 0.0017, which is a very small p-value. And then, so you want to find out how significant it is. So our alpha value that we chosen is 0.01. And so our p-value is less than our alpha. 0.0017 is less than 0.01. So it is the AZT drug is effective, or the evidence that the AZT drug is effective to the significance level of 0.01. So we reject the null hypothesis, which is that the people taking the AZT drug is less likely to develop AIDS than the placebo, according to the evidence. But it is really significant that AZT is effective. So part C, what is a double-blind experiment? And this means that the person giving the drug to the patient and the patient does not know which is which drug. And this is because, well, you don't want the patient to know which drug you're taking, because that will influence their results and their thinking about if it worked or not. And you don't want the person giving it to the patient to know either, because they might give clues or tells that, or might actually tell the patient what it is, which will also hinder your results. So double blind is best when the person giving it and receiving